Welcome. In this video I'll be showing you how to make a moving average fitted line plot and along with it a forecast, and also we'll measure the quality of fit. Um, I'm using this gas use data that I collected at my house for 30 consecutive days. It represents in hundreds of cubic feet the natural gas used in each day at my house. So in an earlier video we saw that making a time series plot out of this data showed a slight downward trend to the data. So when we do a moving average plot, that kind of smooths out the variation, and we're more likely to see the trend. So to start the process here, I'll make a column called smooth values, which in my case I'll arbitrarily make as a 3-day moving average. So let's call this smoothed. And if I want to average 3 days, I'll start in the third day's cell here and say equal average and grab these three observations. So I'm using this point to kind of represent these three. It smooths it out. Double click the lower right corner and you can see the formula copies down correctly all the way. The next cell here in day 4 is averaging these three observations. So that's why we call it a moving average. Okay, so again, remember this is really a 3-day moving average. I arbitrarily chose 3 days to average, but we could do 4, 5, 6 or more, and the more you average, the smoother the series becomes. Let's make another column called forecasted values. And a forecast is the prior day's smooth value. So here in day 4, I grab the day 3 smooth value and then double click the lower right corner. Now at the bottom here, let me freeze the panes first. I'll say view, freeze panes, and now we can scroll down and keep the labels up here. Okay, so imagine I wanted to forecast how much gas I'm going to use on day 30. So I can copy this, day 31, which hasn't occurred yet, but I have this model now that I'm working with, and I can grab the previous day's smooth value. So in a way it kind of takes into account some of the dependency in the series. And this would be my point forecast for the amount of gas I'll be using on day 31, again, which hasn't occurred yet. Okay, go back to the top and let's copy this formula over, and let's calculate our misses or residuals. A residual is the actual value of your series minus the forecasted value. So we have no residuals up here, so I'll have to start with day 4. I say actual gas minus forecasted gas, and for day 4 I have a miss of 3 units, or 300 cubic feet in that case. Double click the lower right corner and you can see some residuals are negative, some are positive. Okay, we're ready to make our graph. I'll highlight the data for the day index, my actual gas use, press Shift Control down arrow, and I'm also going to include the blank cell because I don't have an actual gas use on day 31, but I want to show the forecast in my graph. Press on the Control key and highlight up from the bottom and include all these blank cells up here. And then go Insert, Scatter, connect the points. And there's my graph. And I'll do some editing. I'm going to unfreeze the panes again. So if I go to View, I'm in the chart, freeze pane, okay. So we're near the top, and I want to shrink this so we can see a little better what's going on. Okay, so the red represents the forecasted values, and this series would look just like the smooth values except they're shifted over by one place. So in effect it's also representing a smooth version of the series. Let's rename these series to their correct names. Right click anywhere in the graph area, select data, series 1, edit. Those are the actual gas values. Press OK. Click on series 2, edit. That is the forecasted gas values. Press OK. Let's stretch out this. It still is time series. Let's rescale the y-axis. Right click on the y-axis, format. Let's start at 2, go to 9 by increments of 1, and then also under number, let's get rid of that extraneous decimal place. Press OK. For the x-axis, that goes up to 30, actually 31 I guess. So let's right click, format axis. Let's go up to 31, but let's go up by increments of 7 because these represent the days, and I had no missing data here, so the 7 days of the week. Okay, I prefer no grid lines. Click on it once, delete. Let's add axis labels. Once you click on the graph, you can go to layout, axis titles, horizontal, below the axis. This is my day index. For the y-axis, vertical, rotated. Let's call this gas use. And for a title, let's go layout, chart title, above the chart. Let's call this daily gas use with 3-day moving average forecasts. And let's shrink that title because it's way too large. There you go, so it looks better. And again, we can kind of see the downward trend. Let's measure the quality of fit here. How well do these red squares match up with the blue diamonds? So we can calculate something called the MSD, the mean squared deviation statistic. MSD is equal to this average squared residual. So a function in Excel we can use is equal sum SQ, parentheses, highlight the residuals, parentheses, and how many residual, divide by the number of residuals. There happens to be 27 because we didn't have 3 initial observations here. So 27 residuals, average squared residual. Okay, and then this is in hundreds of cubic feet squared. Let's get it back into original units. So root mean square error is our statistic for that. Take the square root of the MSD. Equal SQRT, parentheses, highlight the value, parentheses, there we go, back in original units of hundreds of square feet. Let's highlight these two numbers and get rid of some excess decimal places. I think that's good enough. Okay, so this says my typical deviation between actual gas use and what this model forecast the gas use to be is 150 cubic feet. Some places, some misses are much smaller than that, some are larger, so this is like a typical miss, an average miss. Okay, that's it for this video. I'll show another video showing you an exponentially weighted moving average.